Okay, so now that I have these two coordinates right here, I'm going to have an equation that kind of represents what x is in terms of y. And I almost always use this. And I can see that my x value, to get my x, I would have to multiply my y by 10. So I know that 2, my y value, times 10 gives me my x. And I can show you another way in class to do that if you want to see a different way. So we're done with step 3. We've written our two coordinates. Now we have to solve for dv. So what I'm going to do is take my x right here and I'm going to substitute it in. So I can rewrite my dv as a 10 times 10y dy, which is equal to 100y dy. And so now step 5 tells me to plug my dv, now that I have that solved for, back into my dw. So this is going to go up into here because that's my dv, and so my dw is going to be equal to the following. There we go. So that's my dw, and now I get to write my final integral for part 2. Remember, it's from 2 to 3 because we're talking about this section right here. Just kidding, it's from 0 to 2. I lied to you. I don't know why that said that. We're talking about this section right here, the part where the x changes. So this is going to be the integral from 0 to 2 of 9.8 times 997. 3.1 minus y times 100y dy. So that's kind of my answer for the second part. And now I get to write the entire answer over, and that's going to be combining my integrals from part 1 and part 2. So I'm going to go back to that integral, which was this right here, and I'm going to write my final answer for this entire problem is going to be that previous answer plus this one right here. So let me get that down. There we go. And so we have our first integral from the first part written right here, and then we're going to add that to our second. So we're adding how much work it would take from 2 to 3. That would be this first part right here, and then our last part, the work to get from 0 to 2 right there. So that was our first problem, and I promise you it's going to get a lot faster. That was just kind of investigating why things work. I want to just emphasize the steps that you need to take when you first see a problem, and obviously you need to read it, and it's the same problem. You can pause the video and read it. But the first step would be to draw the picture. And it states here that we have 6 meters at the deep end and 2 meters at the shallow. So you can see here that we'd have 5 meters, and then, oops, that's be a 4, 5, 6. Okay, so there's 2 meters right there in the shallow end, and then we've got, you can see obviously here, 6 meters in the deep end. And this problem wants you to actually raise it 0.2 meters above the water, so that's why I've got that 6.2 right there. All right, so that's first is to draw that picture, but I also want you to draw your 2 different types of rectangular prisms. So for this section right here, okay, those rectangular prisms are going to have a width of 40 meters, okay, and then it's going to have that depth of 15, or that 15 meters wide, and then it's going to have that dy. So we've got 15 meters as its width, and then we've got this length right here. Okay, and similarly here we would have an x of 15 and a dy. Oopsie. All right, so we're just going to go ahead and solve this entire thing. And I just want to emphasize that our 40 meters long, the long is going to be this, and our width is going to be this, and this will be our height. Okay, so what we're going to do here is we are going to write down our work equals force times distance, and then I'm going to write down my force equals mass times acceleration. Then I'm going to get mass is equal to what times what? Well, it's going to be my volume times my density. So that came from a formula earlier. So my volume, I call that dV, and my density was given to us as 997. All right, so next thing that we're going to do is we're going to solve for force. So force is going to be equal to my mass times acceleration. Okay, we already have my mass, so I'm going to drop that down. And then my acceleration is 9.8 meters per second squared. All right, now my distance, as you're looking at the steps, then my distance is going to be, I'm trying to get to 6.2 meters, so it's going to be 6.2 minus y. All right, now my dW, my work is force times distance. So that's going to be a force, which is going to be dV times 997 times 9.8. And then I'm going to times it by my distance, which is a 6.2 minus y. And I'm at this stage going to block off my work here. The next thing I'm going to do is I'm going to solve for my volume of this. So my volume there is going to be my dV is equal to 40 times 15 times dy. So that's going to give me a dV of 600 dy. That right there is going to go in for my dV. So I'm going to get a dW of 600 dy, and then I'm going to put everything else back in. 997, 9.8, and I do need parentheses around that. Okay, and then I kind of like to put my dy at the end because that's how we're going to integrate. So I'm just going to rewrite everything. You don't have to. Okay, so there's my dW, and I like to now write my integral, and that's going to be the integral from, we're talking about this section right here, so that's going to be from, what is that going to be, from 4 to 6, because it's the, that's that deep end there, because we know that it is 2 meters at the shallow, so we know that this is 2 meters, so that's going to be from 4 to 6. And then I'm going to write everything in here. All right. So I am halfway done my problem. I have my first integral. So I'm actually going to box this, and I'm going to leave room at the end for more. So now I'm going to erase the rest of my work, and we're going to do step 2. Okay, for step 2 here, I have to think about my 2 coordinates. Okay, so remember, I have this length right here, which is going to be 40, 4. My x value is 40, right, because my value there is 40, and then my height is at 4 right here. And then obviously I would have this point down here, 0, 0. So if I have 40, 4, and I have 0, 0, I can say that my x is equal to 10 times my y again. So what I can do is solve for my dV again. So my dV, my volume, is going to be my x value. Okay, my x value is a 10y times my 15 times my dy. I'm just doing length times width times height, and we just found that that x was 10y. So that's going to give me a dV of 150y dy. And so this is going to allow me to substitute into this right here. So my dW for this particular problem is going to be equal to 150y dy, and then I'm just going to recopy all of this down. And remember, I like to put my dy at the end. Okay, so This is going to be a dw is equal to all of this right there. And then I know that I can write this as an integral. And we're talking about the integral from 0, can't see the 0, but it's down there, to 4. So it's going to be the integral from 0 to 4. And I'm just going to write this back. And then my final answer is going to be adding these two integrals together. So I'm just going to go like this and put a plus. So folks, I know that these are very long problems. They're going to look exactly the same though, and so we can get a lot of practice with several more of these problems. All right, thanks for watching. Have a good one.